We'll go ahead and begin. Well, happy Monday. It is fourth week Monday. I hope you guys are all doing well. And today, the topic I wanted to cover is getting data into R. So we haven't had to deal so much with getting data into R yet, because almost like in Data Camp, all of the data is preloaded, right? When you start up R, it's all preloaded. And then so far I think in the homeworks, they've all been, you just write library this, data this, and we've been using data that has been included within a library in R, which I mean, that's good, right? But there's a lot of times, and especially for your final project, the data that you want to work with is not something that's part of a library. It's not part of something, it's not automatically loaded. And so it's very important that we are able to get data into R, and what does that look like? Okay. There is a supplemental text. So our textbook, Modern Data Science in R, doesn't really have a whole lot of stuff dedicated to this topic. It's an important topic, but yeah, we don't have a whole lot of stuff. There is another textbook called R for Data Science. It's an excellent book, and there's a chapter on importing data, and again, this you can read the entire textbook for free in your browser. So R for Data Science, they just released the second edition, which is which is great. And again, just like everything else, you can spend money and buy the print book, but you can read it in your browser as well. So anyway, this chapter 8 on data import, and I've some of the stuff in today's lecture slides I've taken directly from the website there. Okay, so is there a lot of overlap between the reading? Yes, absolutely. But in that case, probably you'll just go to this page as a reference. It's not like you have to read it and stuff like that. Okay, there are a bunch of packages that we can use for loading data into R. R has some native capability for reading in data. In particular, there's a function called read.csv, but I prefer using this package called reader, and this has better performance as far as reading in data. So read.csv will read in CSV files. CSV files are probably the most common plain text way to transport data, at least data that looks like a table. Okay, if it looks like a table, probably it's going to be in a CSV. There's a lot of other data that's a lot more complicated, and if it's more complicated with nested things, you might have a JSON file. That's also very common for more complicated data sets. But if it's like a table with rows, columns, it's going to be a CSV file. Okay. And so you load up reader, and you can read in CSV files. But then there's other functions, other types of files. And so these are all kind of for text files. So you have tab separated files, delimited files, fixed width files, tables and stuff, and then weblog files. And any of these things, if you do find a data set that you're interested in and you encounter some issues and stuff like that, don't hesitate to come to office hours. I have a lot of experience with getting stuff into R, and so and sometimes the reason why it's breaking on your computer could be just something stupid, within your file there's this funny character at the start, and it just blows everything up, and it's frustrating. But these things happen, especially when you download things off the internet. Sometimes whatever, the server inserts a funny character and it breaks things. So anyway, if you're having trouble, come see me. I'm happy to help you out. Okay, so that's package reader. It's part of the tidyverse. So when you load up the tidyverse, reader is automatically loaded, and you'll have read_CSV. So the _CSV is superior to the read.csv command. Okay, there's also a cheat sheet on the kind of readr website Okay, and so this is a handy cheat sheet that kind of covers like, okay, how do you do stuff, right? So if your data look like this, then you'll do whatever whatever you need to do. Okay, so that's package readr. So that's probably going to cover 90-something% of your use cases. Will be read_CSV. Okay. There are other software packages, right? So you have SAS and SPSS and Stata, and I don't know, maybe you've heard of these, maybe you've used them, maybe not. But there are other companies that produce statistics software, and you can use that. And if you want to interact with those, use library Haven. And these ones you're going to have to like install. So you'd have to do install.packages Haven, or you go to the on RStudio, you have to go to the packages thing and you click install to install new packages and things like that. Okay, so that's Haven. Another common file format is Excel files. So if you find a data set and it's stored as an Excel file, then you'll need to install Read Excel. Okay, XL, the letters XL, Read XL. And then you can, read in your data using, read_Excel, and you give the name of the data file. Excel workbooks have you can contain multiple worksheets, and so if you want to specify which worksheet you want to import, then you can do it this way, right? So by default, Read Excel will just read in the first worksheet, but if you have like multiple worksheets, you can say I want to read in the second worksheet, or the worksheet titled this, right? So that's how you would read Excel into your data, okay, into R. And then there's another package called data.table. This is not part of the tidyverse, but this has a function called fread. Fread works very similar to read_CSV, but I guess under the hood in the direct code part, there are certain things that have been optimized that allow it to work very well for really big data sets. So if you have like a CSV file that's like a gigabyte big, okay, then certainly do not use the base R, read.csv. It'll break that, okay. And then read_CSV will struggle a little bit with reading these really big files also, because read_CSV tries to look ahead, and based on what it looks ahead, it tries to make decisions when it's reading in, and that's like a useful feature in most cases. But when it's a really big file, looking ahead actually becomes like a liability, because it's so much stuff, right? So data.table is just like, we're going to read it in as fast as we can. And so if you're dealing with like a really big data set, then I would recommend using data.table. Even if it's not over a gigabyte, if it's like over half a gigabyte or something, like over 500 megs or something, you probably get better performance with data.table and using fread there. Again, if your group decides to use a really big data set, which is allowed, but again, not recommended, just because you don't get bonus points for using a big data set, and using a big data set comes with additional challenges and hurdles. But if you do decide to do something like that, come see me first, and I'll try to provide some guidance, so at least you don't get stuck and hung up and have this frustrating experience, right? So my hope is, with this course, between the project and all of the the data camp and the regular homework and the lectures and stuff, we're kind of approaching this topic of data science from a whole bunch of different angles, and you're going to learn different things from these different things. And the project, I want to be an enriching experience where you're learning stuff, and not like exercise and frustration. And so, I want to give you the freedom to pick your data sets, but also I also want to give you like a good advice, like, okay, you know what, maybe this you can run into some hurdles, or if you're gonna do it, at least I want to give you a little bit of wisdom and guidance there. So anyway, we have that. Okay. Before I forget, let me give you your first view quiz answer for today, which is the letter A. A as in apple is your first view quiz answer. Where did it go? Okay. All right, so that's data table. Data.table has function fread. You can kind of think of it as fast reading. Okay. There's another... sometimes you have data and you find it on the internet, and that's great. And there's like a link that you can just use to download the data. And sometimes you want to give a script to a friend or a group mate, and you want to do that. Then in that case, there's a few ways you can do this, right? You can say, all right, in order to run this script, what you need to do is you need to go to this website and you need to download this file and you need to save it to this location on your computer, right? And then you can run the script, and that's fine. Sometimes you want to just include the instruction in the script, and within the script, when you run the script, it's automatically going to download the file for you, right? And so that like removes the step of having to, like, I don't know if you've ever like tried to give someone instructions, like teach your grandparents on how to use their phone or something. Like sometimes it's like, I wish you could just push this button and it does everything for you, right? So sometimes you want to have the instruction for downloading the file inside your script. And so if you want to do that, you want to install this package called Downloader, right? And then you call library downloader. And then you say, I don't want to actually go to that URL. Okay. Then you can have some place on the internet, some web address on the internet that links to some CSV file. All right. And, you say, this is my URL. This is just a text string, right? And then so if you just copy and paste that into your browser, it'll take you to the web file. And then you'd run this code, download. Where do you want to download? URL to where? And then you specify the name of the file that you're going to download to. File equals iris.csv or whatever it is. And this will automatically get saved to your working directory. So by default, the working directory is wherever your file exists to begin with. And so if you downloaded it to your downloads folder, then your downloads folder will be your working directory. I always recommend for your homeworks and for your projects to make a designated folder on your computer for your homework or project. Put everything related to that in that folder. And then so, if you're in the homework folder, your homework folder will be your working directory. So anyway, you call download, and that will download the file. And then once it's downloaded, then you can call read_CSV and load up the file that was downloaded. So that's a nice little thing. Okay. Read_CSV actually has built-in capabilities for reading things directly off the internet too. So you can also just do read_CSV and then just give it the URL directly. Okay, but that won't download the file. That will read directly off of the internet. And then there's pros and cons to doing something like that. Okay, but if you want to include like instructions for downloading the file, you can use library downloader. Sometimes you want to save an object for future use or to kind of give to a friend or classmate or groupmate. And so you can use this command write.csv. Write.csv can be used to export things, okay? There's also save. And so, within R, as you work, you'll have, these data frames, these tibbles, and you can save those objects by name. And basically, you just name the objects, object 1, object 2, and then you can save it as a RData file. And the RData file, you can give that, and somebody opens the RData file and will load all of those separate objects into their environment in R. Okay, so like in RStudio, so in your environment, I have a whole bunch of this stuff. And you can say save workspace as, and you can save it somewhere into our data, and then you can transport that. One thing I often recommend is just like clearing out your environment. At the start of every time you start up R, I recommend clearing out your environment rather than loading stuff, but that's like a separate issue. But also, if you want to just save certain data frames or tables or whatever, okay, you do write.csv, file equals something.csv. So here I'm calling it df.csv, or table one, students.csv, whatever you want to call it, and you'll do that. Okay, if you want to write, if you don't have a table and you just have a vector, right? So in R we have vectors and we also have data frames, right? So if you want to write a vector and save that somewhere, you can just do write, and that will save it as a plain text file. Okay, and then write.csv will save basically tables as CSVs. The default behavior of write.csv is that it includes row names, which in my preference, I don't like saving the row names because the row names are usually just like 1, 2, 3, 4, 5, 6. So I don't like that. So I often use this option, row.names equals false. But again, however you want to do it. And so that's one way for you to kind of transfer file or information from one person to the next. Okay, and then and there's also a package called Lubridate, and this allows you to work with date variables. Okay, so here's a question, or I don't know if I already asked this question. Are dates, so like today is April 24, 2023, are dates numeric variables or categorical variables? Yeah, what do you think?
Numeric.
They're numeric, okay. And what's your answer for that?
Isn't it like stored in seconds after like some specific point?
Yeah. So it's actually a kind of a modern wonder that the entire world runs on the same calendar, right? And yeah, our calendar is based off of a day of religious significance, right? And so you so 365 days in a year is kind of like determined by astronomy, 300, and having a leap year every 4 years and stuff. That's kind of an astronomy thing. But it's like, why do we have 12 months, right? Why are the months separated into these chunks of arbitrary, like 30, 31, 28, 29 days? And it's very arbitrary. It's very kind of strange. And then, why is, if you think like December, DEC is usually like for 10, but it's like the 12th month, and September, October is 8, but it's like the 10th month and stuff like that, right? Calendar actually used to start in March and whatever. Okay, but anyway, all sorts of weird stuff, but yeah, it's just, we just have this kind of weird way of kind of storing the thing. But you can think of it as just like how many days have passed since this, January 1, year 0 type of thing. And then the way the computer stores it is how many days since what's known as the computer epoch, which is January 1, 1970. And so if you look at January 1, 1970, that's like the value, either 0 or 1 on the computer, and then I think it's a 1. And then January 2, 1970 is stored as a 2, and so on and so forth. And so January 1, 1971 would be like 365 or 366 or something in the system, and so on and so forth. And it's however many days have been since. Okay, so anyway, dates are stored as numbers, and then seconds. For times, it's also like seconds since the epoch and stuff. So anyway, working with dates in R used to be very, very frustrating until Lubridate came along, and it made things much, much nicer. Okay, this slide, don't even bother with any of the code on this slide. The only reason why I included this slide and the next slide is just to show you how much of a pain it was to work with dates in R. So before LubraDate, there was a function in R. There's this function still exists. It's called as.date, and you basically have to turn strings into dates. And so if you had something like January 15th, 1999 stored in the computer, you'd have to use something like January is %B, 15 is %d, and year is %Y. And if you do that, then the computer recognizes, okay, this is 1999, January 15th, okay? But if you leave out this comma, then the computer says, oh, I have no idea what you're talking about, right? If I say take this date and try to make a date object out of this, it breaks and stuff like that. If you have something like this, 12/15/2001, and you try to turn that into a date, you need to have the dashes, and you need to have %m to indicate that the date was stored as a 12 and not January. And if you change anything up, it just gives you a missing. It says I can't do it, right? So again, it was very frustrating. This is just more examples of how frustrating it is if you have here we can say January 15, 1999, December 15, 2001, March 18, 2002, and we recognize these are all dates. But again, with as.date, it could only accept one kind of format at a time, and you can say, okay, well, I can either recognize the January 15th or the December 15th or the March 18th, but it can't do all of them. So it was really frustrating. And again, don't even try to learn any of that code. Okay. Now we have LubraDate, and all we do is we just say, hey, we're in America, and so we store our dates as month, day, year. And LubraDate's like, oh, month, day, year, I can do that. And it says, okay, January 15th, there's the date. December 15th, there's the date. And March 18th, there's the date. Okay, and it looks like this is all just, it looks like it's just date information stored as a string because they're in quotes. But internally, after you use LubraDate, internally, it changes it from kind of text this way, and it turns it into the numeric form that the computer uses, which is how many days have passed since January 1, 1970, or something like that. Okay, LubraDate does require that when you say month, day, year, all of the dates have to be a month, day, year. So you can't mix American dates and European dates, right? Because if you have 7/8/23, is that July 8th or is that August 7th, right? And so that's going to be so you can't mix that. You have to do it. So here's a ambiguous date 03, 04, 05. And so you have to tell LubraDate how the information is stored. Is it year, month, day? Is it month, day, year? Is it day, month, year? And LubraDate will figure out all of these things. If you try to give it something like this, if you give 25/12/99, which we would recognize as Christmas 1999, but you do month, day, year, LubraDate will say, nope, that I can't do because there's no 25th month. Okay. But overall, if one of your columns has date information, and especially if it's a field, a text field where, I don't know, you ask somebody enter your birth date, and it's not validated or something, then working with date information, definitely you'll want to use LubraDate to work with date information there. Okay. All right. Let me give you your second UQuiz answer, which is the letter C. C as in cat. C as in cat. All right, so we are going to use, using readr, and we need to, there's a file, students.csv. Okay, you know what, let me upload this to, I forgot, I need to upload this to the thing, see if you wanted to follow along. Students.csv. Okay, so if you wanted to follow along, here's the students.csv file. Okay, so students.csv file. So CSV files are just stored as plain text. Okay, and this is what it looks like. So if you were to open a CSV file, would say open it with just like a notepad, this is how the, how do I zoom in here? I don't know if you can read this. It's just plain text. It's just, it says student ID, comma, full name, comma, favorite food, comma, meal plan, comma, age, and then 1, comma, Sunil Huffman, comma, strawberry yogurt, comma, lunch only, comma, 4. All right, so it's just stored as plain text, separated with commas. And so this is how the data is stored. And then we tell our, I want to read this in, okay? And so we use this function, read underscore CSV, and we say, I want to read in students.csv. We put the name of the file in quotes, and then we say, store that into an object in R. We're going to call it students, and this will just create a data frame, okay? A table or a tibble on in R. Now, by default, whenever you use read underscore CSV, it kind of gives you the status message at the end, and it just says, okay, these are the columns that I've discovered, right? It says, okay, these are the column names: full name, favorite food, meal plan, and age, and these look like they are character columns. And then we have a student ID, and that looks like a number. So in R, you have numbers which get internally stored as either doubles or integers, and by default, most numbers are going to be doubles. Okay, it's called type double, and they're floating point numbers. Basically, it allows you to have decimal points if you need to. Okay, so even if you don't, so just by default, R is going to say, okay, whenever I see a number, I'm going to assume people sometimes want the option to have decimal places. And so even if it only gets like 1, 2, 3, it's going to say maybe somebody wants to do a 2.5. Okay, so by default, it's going to use type double, which allows for decimal places. You can tell R, this is whole numbers only, integers only, and you can say integers if you need to. But by default, it's going to try to say, okay, these look like words, so they're going to be characters. These look like numbers, so they're going to be double. And it kind of gives you this status message afterwards. Okay. I like the status message that it prints out after it reads in. A lot of times it feels scary because I think the text comes in red, and sometimes in R you feel like red text means an error message. It doesn't mean an error message. It just means, okay, this is what happened and I'm happy to report this. Okay, I like that. Now on the following slides, I put in this option, show column types equals false, and this will hide the output message after reading in the data. So, and usually I like seeing all of this, but in order to get the code to fit on the slides, I'm putting in show column type equals false. You don't have to use it, but again, but that's what we have. Okay, so anyway, after I read in the data, this is what it looks like, okay? And it says student ID, double, these are numbers, full name, it's got the people's names, favorite food, it looks like this, meal plan, it looks like this, age looks like this, okay? One thing to note, okay, is in the file, okay, who is this? Leon Rossini didn't have an age, okay? And so R says that value is missing. What's Leon's age? Unknown. We don't know. That's what this is, okay? All right, person 3, Jayendra, okay? For the favorite food, they entered N/A, okay? And right now, R just says, okay, that is the input, and R doesn't know that this means missing or not available. This, to R, this is like, oh, is there a food called NA? Like, I don't know. I don't know. What kind of, like, new apples or something? I don't know, right? So R doesn't know what this is, and it just says, okay, this is what it is, right? Now we recognize and say, oh, this person meant to say this is a missing value. This is something that's unknown. And so what we can do is we can specify and say, you know what? Anytime you encounter this thing in the text, that means it's going to be a missing value. Oh, okay. I'm jumping ahead of myself. So here is an example where the CSV file is available on the internet, and so you can just give the address of the CSV file, the URL of the CSV file, and you can just do read _ CSV and then the web address. Okay, And then and here again, I got show column types false, so it doesn't report the message. And you don't have to necessarily write, use library downloader in that case. So you can kind of load the data in. This way, this is also a way to do it. Okay, so here on this one, I said I'm using this argument NA equals, and then I'm giving it a list of things to use to convert. Anytime it encounters this string, it means it's a missing value. So if it encounters n/a, replace it with a missing value. Okay. If it encounters nothing, okay, and this is basically an empty string, meaning for after Leon Orsini there was nothing there. We're going to say that means it's missing. Okay. Sometimes, depending on the data set and the agency that you're downloading from, sometimes they put stars in for missing values. Sometimes they put in a question mark. Sometimes they put in different symbols, or they have a dash or something to indicate missing. And so you would specify NA equals star or dash or whatever it is. Okay. And so that's a way for us to identify missing values. Okay. You'll notice these column names, we have student space ID, full name space, and then favorite.food and things like that. When you're working with tables in R, having spaces in your column names it makes things just more painful to work with, okay? Because by default, R is not expecting spaces. And so if you want to use spaces, you have to put backticks, right? And it's not impossible, and it's fine, okay? But you got to use backticks for everything if you want to have a space. And so a lot of times, and then and it makes RStudio, I don't know if you've noticed, you have tab completion. So if you hit tab as you start typing out a variable name, if you hit tab, it'll finish the rest of your variable name, which is a really nice feature. And I think tab completion is actually smart enough to handle the backticks, but you have to kind of start it off by saying backtick, student ID, and stuff like that. So anyway, it's a lot of times it's nicer to just have an underscore, and you can do student underscore ID or full underscore name and things like that, okay? And so here, I'm just reading in the data. I'm doing read CSV, read underscore CSV. Here's the NA stuff, okay? And then we're going to pipe that into rename, okay? And again, the result, whoops, and I don't want to highlight that. And then the result we're storing back into students. So what are we doing? We're renaming what the original title, student space ID, and then full space name. And this is case sensitive. It has to match exactly. And then we're going to replace it with student underscore ID and then full underscore name, okay? So that's how we can rename them. That's a manual thing, okay? There's a package called Janitor, okay? And again, you're gonna have to install this package, and you do install Janitor, okay? And if you okay, I already have it installed. I want to install it again, but there is within Janitor, there's a function called clean names, okay? You can call library janitor, or if sometimes you just want to use one function that exists inside of library and you don't actually want to use the library, load up the entire library, you can use just that one function without having called library janitor by just writing the function package name : and then the function name. So you can do library janitor, and then clean names will be available. Or in this case, we just want to use clean names, and so we can do janitor : clean underscore names. Okay, and then clean names, what this function does is it automatically does name cleaning for you. It says, oh, here's some spaces. I'm going to just replace the spaces with underscores. And it will go through, and its kind of default behavior is make all of the column names lowercase, okay? Which, maybe you want, maybe you don't want. So if you look here, age is all caps age, and it's going to make that age, okay? And then here, meal plan. So there's all kinds of funny things going on. So it sees the capital letter in the middle So it's not, janitor isn't smart enough to know all of the English words and say, oh, here's the word meal and here's the word plan. But it sees the capital letter in the middle of the word and it goes, oh, okay, I think this person's saying there's a second word here. Because that's it's called camel case, where you have like to differentiate words, you use capital letters to differentiate things. So it says, oh, okay, you know what? There's two words, meal and plan, and so we're going to put an underscore there and make everything lowercase. Okay, and then it also does a thing where it says, you know what? Let's stay consistent. Rather than having dots for some of these things, let's replace them with underscores, and it does this. All right, so janitor, clean names, just kind of does these default things to clean up the names, and it's actually pretty nice. It works pretty well. You don't have to use rename. So rename is perfectly fine, and it's great, but it's also, you know, a tiny bit tedious. And then janitor, clean names, like it works pretty well. So that's a nice little thing. Okay, again, all of this stuff is optional. You don't have to rename any of these columns. If you want to leave it just like this, that's allowed. Okay, but everything is like, to make your own life easier, it's nice to have some of these cleaned up things. Okay. This column, meal plan, okay, right now we have lunch only, breakfast and lunch only, breakfast and lunch only, and so this is, I guess, like in an elementary school, like, you know, students can be on different meal plans, and how do we want to do this? Right now it's stored as a character, okay, which just means it's just treating it like words, okay, but what we might actually want is we might want to say, you know what, there's only a couple options, right? We can have lunch only, or we can have breakfast and lunch. There's no option for like dinner and snacks or something like that, okay? And so we don't want people to just be able to insert whatever words they want here. It should be just kind of like certain options. And so if you have a categorical variable where only certain options are available, you can, in R, you can kind of store that information that says like only certain options are available, and you turn that into a factor. Okay, you obviously would not want to use a factor for something like a person's name, because there's not only a limited number of names available. You can have however many, I don't know, an unlimited number of names, right? And favorite food, you know, we don't want to have just certain options either. But for something like meal plan, where there's only certain options available, it makes sense to turn it into a factor. Okay, and so in that case, we'll just mutate. Okay, and mutate is often used to add a new column. But if you give the same name, the name of a column that already exists, it's going to replace the column. So here we're going to say turn meal plan into a factor. So we do factor on meal plan, and we're going to store that back into meal plan. And so that will just replace the existing meal plan column with a factor or a categorical variable version of meal plan. And so that works there, okay? And that's that. I skipped, there's one more thing, and it's in the R for Data Science book, and it says, you know what, let's look at this age thing, and then let's replace 5 words with the spelled out F-I-V-E with the number 5, and then let's turn age from character into a number, because this is kind of annoying, because we might want to do some, you know, math work and say, like, what's the difference between, you know, Sunil's age and Jayendra's age, and we want to say 3, but right now as a character we can't do subtraction or addition or things like that, calculate the mean. Yeah, question.
What does representing as a factor do?
Representing as a factor, again, will limit the what values can be stored in there to just kind of a certain number of values. And you can actually, if there is like a third meal plan that we haven't listed, when you specify a factor, you can, the different options are called levels, and you can say lunch only, breakfast and lunch, and maybe there's a third one, breakfast, lunch, and dinner, or something like that, right? It's hard to imagine that being at a school, but you can have that, and you can say, okay, these are the three different levels, and you can store that. And basically, if at some point in the future somebody tries to enter a different value into the column, it's going to put in a missing. It's going to say, you know, somebody tried to put in, I don't know, dessert. And that's not a option that's available. So we're going to just treat that as like, I don't know what they're talking about. Okay. So factors basically limit what kind of values can go into a column, which in some cases, it's kind of like, I don't know, like, you know, at the ice cream store, there's only a certain number of flavors that you can buy, right? And so you can say, all right, what was the order that they did? You can have a factor there, and it will only be certain choices. Okay, and that also helps eliminate like spelling differences and stuff. So, you know, as like you know, when you fill out your mailing address or something, you might have like what state you can choose from. Okay, and you can choose, you know, California or, you know, Arizona or something like that. And you can imagine if it was just a free text field, somebody could type in CA, somebody else could type in California, the full thing. Somebody can write Cali, which, you know, they're not from California if they do that. But, you know, they could type in something, type something in, and you might have spelling differences. And then then it gets annoying to have to do some kind of analysis. So if you just say, okay, you are limited to one of these 50 states, right? That would be a factor. And you can say, you know, you can have a whole bunch of options, like 50 options, or if you country, you can have like, well, I don't know how many countries, you know, 193 countries or something, 94, whatever. But basically a factor just limits what values can be entered versus like a name. You don't want to limit what options somebody can pick for a name, right? So, so that's what that is. Okay. Last bit, and then let me go ahead and give you your last view quiz answer for today, which is, I gave you two, right? Okay, last one is E. E as an elephant. E as an elephant will be your last view quiz answer. Okay, all right, so lastly, you know, when you get your data into R, it's going to store it as a data frame and a tibble. A tibble is basically like an enhanced version of a data frame. When you're working in the tidyverse, everything kind of becomes tibbles. And I just want to kind of show you a few commands that we can use for either selecting rows, selecting columns, or extracting certain values out, okay? And we've already seen some of this stuff, but I'm going to just show you again. So if you want to just get like the second row, so again, here's kind of our data right now, okay? Let's say we just want to get the second row, okay? Then we can do slice, okay? Slice 2 will pull out the second row. Okay, you can also use square bracket notation. And so, you know, if you read someone else's code, you might see it like this. And you can do students, and then you use square brackets, and it'll be 2 comma, okay? With the square brackets, and you're working with a table, before the comma is which row, and then after the comma is which column. So in this case, we want the second row, all of the columns. So we're going to do 2 comma blank, and that will be all of the columns. So in the second row, and we get the same information. Okay, so we can say slice out the second row, or we can just say square bracket 2 comma. If you want to select multiple rows, you can do slice, and then you give a vector of which rows you want. You don't have to put them in order. Okay, and you'll get them back in the order that you specify. So if I say I want the third row followed by the second row, slice 3 comma 2 inside a vector there, you'll get the third row followed by the second row. Okay, you can do the same thing with the square bracket. You can do students square bracket C 3 comma 2, and you'll get the third row followed by the second row there. Okay. You can also specify like a range of rows. Okay. So here I can do slice 4 colon 8, and that's basically says I want rows 4 through 8. Okay. Now our table only has 6 rows in it. Okay. So when you do slice 4 through 8, it's going to come back and it's going to just give us rows 4, 5, and 6. Okay. There is a difference between using slice and the square bracket. When you use the square bracket and you ask for rows that don't exist, it's going to give you back basically what would have been, right? 4, 5, 6, and then you would have row 7 and row 8, okay? but it says those don't exist, so we just have a whole bunch of missing values. So there is a little bit of a behavioral difference when we use when we specify rows that don't exist in our table. Okay, so so we have that. Okay, so those are selecting out rows. Selecting columns, you've already seen the select function, so we can do select to, and that will give us the second column, right? The second column. First column is student ID, second column full name, third column favorite food. So we can do select to, and that will give us the second column. Or if you want to use square bracket notation, you can do square bracket, comma, to, okay? So space, if you don't specify anything, you're going to get all. So we're going to say all the rows, just the second column, and so we get the second column. Okay, and basically we get a tibble of just this thing. You can specify multiple columns, so I want to say select the second through the third column, and so we get a table with the second and third column. Okay, same kind of thing with square bracket, comma, 2:3. So again, these things work the same way, right? And then you can specify coordinates, right? So if we say we want the second row, third column, okay, that is Barclay's favorite food, French fries, okay, and we can specify that, and we can do square bracket 2:3, and that will give us second row, third column, and it gives us this tiny table with just one value in there, and that's French fries. Okay, you can also do it this way here. You can say I want to select the third column, and I want to slice out the second row. Okay, and that will give us, again, this tiny little table, 1x1 table with the value French fries in it. Okay, if you want to get a vector, right, something that you can actually work with, then there's a couple methods. One is you can use double square bracket notation. Double square bracket will extract out the values. So again, single square bracket, if you just do single square bracket, comma 2, this will give you the second column, okay, on the table. And here, if I do double square brackets will do columns only. You can't double square bracket a row, okay? So double square bracket 2 will give you the second column as a vector. So this is a vector of 6 values, 6 names, versus over here, when I did square bracket comma 2, this gives me a table or a tibble of 1 column with 6 values in it, right? So this still has this is a table structure, 6 values, but 6 values in 1 column, versus this is a vector with just 6 values, right? There's a difference there, okay? And then if you say, I want the second column, third value, that will just be this value, J. Andrew Lin, okay? Just this, just the one name in there. Versus back here, we're getting a 1x1 table with 1 value in it, okay? So this is a table, and then this is just the value itself. So sometimes you want the table, sometimes you just want the value itself. And so if you want the value itself, this is one way to do it. Double square bracket, and then so here I'm chaining 2 things, okay? So you learned like single square bracket to just pull subset 1 value in a vector, right? So here we're chaining, double square bracket gives you the vector, and then we chain the single square bracket 3 to say I want the third value in this vector, okay? Another thing is you can use $sign notation. $sign notation, and you give it the name of the column. So full name will give us this. That's the column with that. You can also say I want the second and third values from the full name with these single square brackets, okay? And then another function is you can use pull. So you can say I want the second column. So select 2 gives me a table, and then if you do a table with 1 column, then you can call pull, and that will turn all of the values in that table into a vector. So here I can say, select the third column, slice out rows 2 through 3, and so at this point, it's a table with 2 rows in it, and then we can do pull, and then it turns those into vectors. Okay, so these are just options for dealing with tables and getting their values out. Okay, we will end here. Have a great rest of your day. Today's office hours will be online only. So I got to take off after this, but today's office hours will be online only, but I'll still have them. Okay. We'll see you on Wednesday.